Hello everyone, how's everybody doing? I hope everybody had a good New Year, Happy New Year. Okay, I certainly did. I did fine. Well, I want to just say that this channel is about rational science. What we do here is science. It's called rational because we do something different than what the establishment does. So if you came to get new ideas or a different perspective, you came to the right place. You might think at first sight and first hearing that, well, everybody says that. No, this is different. And if you stick around, you'll realize that that's the case. What we do here primarily is physics, okay? But sometimes we branch off and digress and go on a tangent and do some other subjects like we've been doing lately, philosophy. We've been dealing with Ayn Rand, and also we've been doing extinction, the extinction of man. Quite a popular subject, really, and extinction of past animals, right? Animals that died long time ago. And yeah, I'd like to start this year. In fact, I started the other day, but really I was finishing off 2019, and I really start the year today. And today I'm going to do geometry. But before I do, I want to kind of tie some loose ends on extinction. I've been doing extinction for now at least 20 years. And I can't seem to get the message through. And I'm not talking about people believing in the theory. I'm talking about people understanding it. Right now I fear that there's a lot of people out there that don't understand it, partly because they have different set of assumptions, okay? And yeah, if you have a different set of assumptions and you're not listening to my assumptions, then there's going to be a contrast, okay? We're going to have differences, okay? So yeah, I've heard it all in 20 years, but there are many things that are repeatable that you hear over and over again, certain questions and things that pop up over and over again. And so what I've done is I made a little bedtime story to kind of synthesize what some people say out there. Well, lots of people really say out there, or the answers they give me, or the questions they have. And it gives you an idea, at least from my point of view, that these people did not understand squat of the theory, okay? Just because of the answers they give me and the questions that they ask. I can tell the guy wasn't listening, or he thought this was business unusual and said, oh yeah, I've heard that before. No, you haven't heard what I propose here. You won't find it anywhere on the internet. So if you think that you heard it before, then you're not paying attention, you're not listening. So what I did was I did a little bedtime story that you can tell your kids, okay? And it kind of puts it all together, the type of questions, irrational answers that some of these people give also, you know, to the issue of extinction. Kind of put it in a little story so that we can get it rolling here, okay? So let's see if we can do that. The action takes place 65 million years ago, and in the tradition of Plato and maybe Socrates, for sure Galileo, it's going to be a dialogue, okay? Dialogue between two triceratopses, okay? Triceratops was a herbivorous dinosaur, probably the last big one that was on Earth of the dinosaurs. And they probably made their last stand in Hell Creek, Montana. That's probably the last place where there were at least big dinosaurs, right? And so this story takes place then. It's a dialogue between them. And let's see if you can more or less place it into what these people say today about how to survive extinction, why the extinction is not going to happen, and that sort of thing. What's happening really here is that you know, like I said in a couple vids back, what happens is, you know, these people don't know anything or haven't done any research on extinction, on the extinction of the animals that have become extinct. But they're all experts. They're all experts on why man won't become extinct. And that's the problem. And these people think that we're not going to suffer the same fate as the animals in the past because we humans are not animals. And you say, what do you mean we're not animals? And they say, well, we're animals, but we're not. That's the answer. I get a yes and a no. And so we either are animals or we're not. We either use the word animal consistently or we don't. That's the problem. And right now they're saying, well, we're animals, but we're not animals. What do they mean by that? Well, the animals died because they were dumb and we're smart. And so we won't die like they did because we have technology, we have intelligence, we have foresight, and we're not going to suffer the same fate. And so the question is, are we different animals? I mean, what kills an animal? Why does an animal die? An animal dies because of the same things a human dies. It dies of disease, an accident, maybe genetic stuff or old age, lack of food. These are the reasons an animal dies, an individual animal dies. And we die for the same reasons. I mean, you cannot have a different reason for humans than for any individual human than you have for any individual animal. We die for similar reasons as any other animal or any other mammal, especially in the wild kingdom. And so they say, well, yeah, okay, but when it comes to the species disappearing, we're not like them. That's where they establish a distinction. Why? Because, well, some people say we have trade. They don't have trade. We have intelligence. They don't have intelligence, and so on and so forth. That's when we become non-animals. It's like the biological factors don't matter anymore. Okay. Anyways, here's the discussion between two triceratopses. Okay, and the name of one of them is Bill Longhorn, and the other one is Joe Tiny Tusk. Okay. And let's see if we can just tune into their discussion, see if we can listen to what they're talking about. Okay. One says, how did our ancient brothers, the amphibians, disappear? How did the archosaurs die? Well, our Triceratops herd leader, Big Bull, told us that it was an asteroid, and he's an authority on the matter, so I take his word as law. There is also another theory that says that there was a volcano eruption in those days. Others rumor that gamma rays from a nearby supernova perhaps zapped the Earth and took the fool's breath away. They ended up gasping for air. Okay, and of course there's also the ever-present climate change. It's so hot these days, don't you agree? Even the ginkgo coconuts are melting. And there's anoxia and methane sprouting from the deep oceans. And dust clouds that eclipse photosynthesis. Who knows? Who cares? I mean, what do you think we are? Animals? We are not amphibians or insects or birds or fish. We are triceratopses. We are bigger and mightier than anyone before us that ever will or that ever will be. We can withstand anything Mother Nature throws in our path. But Joe, our world is obviously coming to an end. As you can see by the Cretaceous terrestrial revolution graph, plant species and numbers are disappearing. Angiosperms are taking over the land. The flowering plants are reducing our sources of food. Oh, I'll survive. I'll plant cycad seeds in my personal meadow. All the other triceratops will eat their hearts out. They'll just watch and starve to death from the other side of the fence. Just in case, I can also produce conifers artificially in my personal jungle garage. I eat pine tree bark and shit Christmas cones. Did you know you can eat those artificial cones and how tasty they are? Anyways, worst case, I'll survive by trading magnolia leaves and grasses for ginkgo stems. If we could just get those Illuminati T-Rexes off our backs. Tiny Tusk, we lost our genetic diversity. These tiny mammals that scurry about at our feet have more genetic diversity than our entire herd of triceratopses. Our population pyramid is definitely and irrevocably overturning. We are becoming older and having fewer kids. You're panicking unnecessarily, Bill. That doesn't lead to extinction. If most of the triceratopses die out there, me and the missus here, we will produce new generations of triceratopses and populate the world again. That's the type of dialogue I've been engaging in for 20 years now. Those are the type of replies I get. And apparently, these people have it in their minds that they're going to survive. Triceratopses knew better. They had more intelligence than some of these people. Anyways, I thought I'd tie some loose ends there, make it plain that the answers I've received are not even worth considering. And again, the great problem is that people do not do research on past extinctions. They do not address the issue of whether food has anything to do with extinction. And even when all that is said and done, then they say, well, we're not animals anyway, so we're not going to die like them. And what else? What else can you talk? I mean, that's it. That's the summary. Okay. Anyway, today I begin a little bit of geometry. And I picked on geometry to start the year because that's the foundation of mathematical physics. Okay? Yeah, it's the foundation of mathematical physics. You have both math and physics, and they kind of merge. Here I have a little Venn diagram, puts it in perspective. Geometry is an attempt to merge math with physics. That's what it is. You take the physical objects from geometry, and you take the angles and the numbers from mathematics, and you put them together, and you end up with this thing they call geometry. Okay? What I'm going to argue is that geometry is an irrational religion. Geometry is an attempt to merge the unmergeable, that which is irreconcilable. You cannot merge physics with math, math with physics. Math is math, physics is physics, and never the twain shall meet. Okay, that's the way I've always put it. Physics deals with physical objects. Math deals with quantities, measurements, and calculations, equations, So what does one thing have to do with the other? Math describes, physics explains. Again, nothing whatsoever math to do with physics. Okay? That's going to be my argument. So you know in advance already. And if that's not new to you, okay, well then good for you. You heard it somewhere else. Yeah, math has nothing to do with physics, physics with math. In fact, math has nothing to do with science whatsoever. That's going to be the argument here. We do not use math in science, and the reason we do not use math in science is about explaining, math is about describing. That's why math has nothing at all to do with science or physics. Physics, on the other hand, is a branch of science, and in science we explain rationally, and in physics we explain mechanisms and causes rationally. Okay? And I'm not going to get into the word rational because I've done that in the past, but I will again for those who missed it in the future. Okay. Anyways, the foundation of geometry is the point. And you probably heard of the point somewhere in high school. Everybody takes at least one course, I guess, in math or geometry. They've heard of the word point somewhere, or line, right? So I think everybody to some degree is familiarized with the word point. The question we're going to analyze is, what does it mean? What does it stand for? What does this word stand for? And it's the foundation of geometry. And geometry is the foundation of disciplines such as quantum mechanics and general relativity. I put a little chart here. Okay? and puts it in the right perspective again. So geometry is the foundation of math phys, okay? The point is the building block of geometry. Okay, so geometry is foundations of mathematical physics. I don't call it physics, I just call it math. Mathemagics, I call it, because they explain everything with magic. And the point is the building block of geometry, so you can see how important the point is to mathematical physics. Quantum mechanics and general relativity invoke the point, okay? Quantum mechanics, particles are point masses or charges or particles or corpuscle, whatever they want to call it, okay? So that's what how the point enters quantum mechanics, the world of the small. It enters the world of the big as well, because in GR, an event, which is also the bread and butter, the building block of general relativity, the event, four coordinates establish an event, the location or whatever they mean by that, because that's not clear either. The event is a point in space-time. That's how it's defined. So the point is important for both general relativity and quantum mechanics. And even string theory invokes the point when it builds its lines. From there they go into branes and so on. And so the issue is, you got to resolve the point, because it's the foundation of geometry, which is the foundation of mathematical physics, both general relativity and quantum mechanics, primarily those two, and string theory way far behind, right? And so we need to figure out, what we mean by this important word. I mean, this is an important word in mathematical physics, the point, okay? Now, what is geometry? And that also puts it in perspective. And here you have a couple of statements. All these that I'm going to mention are going to be from official sources, okay? These are from universities, from think tanks. These are all official sources that I'm going to be putting up here. I didn't put their name because I don't want to embarrass them, but if anyone asks me for the references, I've got them, okay? Geometry is the study of shape and size. Geometry was probably first developed to measure the earth and its objects. Another fellow says, or another site says, geometry, the branch of mathematics whose primary subject is spatial relationships and shapes of bodies. Okay? Geometry studies spatial relationships and shapes while ignoring other properties of real bodies, density, weight, color, etc. Okay? Okay, so where do we put the point in all that, in that context? Well, here you have statements, and say we may think of a point as a dot on a piece of paper. A point has no length or width. Okay? And another fellow or another site says a point has no size. Points are infinitely small. I like the fact that no size and small, kind of, they don't go together. Either it has size and it's small, or it doesn't have size. And you can see how all these mathematicians don't care about qualitative aspects and just blab nonsense, contradictions. They don't even realize what they're saying. But, they always put a little dot that looks somewhat like that, and that one to me, I don't know, maybe my eyesight is failing me, I don't know, but it looks like it's got width and height. You tell me if you think it's not true, okay? Okay. But yeah, we do have a problem because these people are saying that this thing is small, but it has no size. I can't reconcile those two statements, to be honest with you. But, what I see there seems to have size and is small, yeah, sure. But then, what are they saying? Okay, so here we have, we look up, to see if we can find a definition of the point. And I went through YouTube, and there's several people who explain geometry. Okay, and so they go out there and they start with the foundations. They start with point, line, and plane. Okay, and so I said, well, let's see what they have to say about the point. Okay, I think it's a fair thing. That's where you're going to learn. You're going to say, okay, let's see what a point is. And this one guy, he starts out, he says, points, lines, and planes, undefined terms. And there you see him pointing at the point. And he says, well, that dot and the word point and all that stuff that I'm pointing to, it's an undefined term. Okay, I don't know, maybe this guy got his degree from Harvard University, and that's why he knows nothing. These 30-degree colleges third level colleges, you know, they don't teach you anything, and it's just for getting jobs. And so this guy must have studied over there. I don't know, Harvard or Cambridge, you know, one of those. Well, let's see, maybe someone else knows or has a better idea. And here's another one, and you can look these up yourself on the internet. You'll find them in YouTube. It says section 1-1, points, lines, and planes, undefined terms. And there you have point A, which the guy is scribbling there on the board. And he says it's an undefined term as well. Oh, maybe this guy studied at the same school the other guy studied. I don't know. So I went to another site, and here they don't even define it. They just go in there and they give examples. Okay, and these are the examples they give. They say, oh, these are points. So I don't know what a point is, but these are examples of a point. And I'm sure if I look at the ice cream cone or the tip of the pencil or whichever one of those, I'm going to find that it's got width and height, or, you know, some size. It's probably three-dimensional. And no matter how far I go to the last atom, I'm going to find a three-dimensional atom. So I don't know what they mean by point. Are they saying that the point is a tip of something, and that tip is one atom, and that atom is what? Three-dimensional or zero-dimensional? Which is it? Okay, so yeah, I've got a little bit of problem with all these people skirting the definition, saying, well, I'm not going to define what a point is, but I'm going to use the word. I'm going to use the concept or the object or whatever. And then telling me it's the same thing as the, what is it, a tip of a pencil, right? And if I look at my pencil, if I look at the tip, I can see it. And so that tip must be made of many atoms, so that's got to be at least 3D. But okay, take it to the limit. The last atom, the very tip, well, that atom has to be 3D. And so how can they say it has no size when the examples they give are 3D? Okay, so we go to another one and see if maybe someone can resolve this issue. And this fellow says the same thing as the others. He says, points, lines, planes, undefined terms. An undefined term does not have a formal definition, but there is an agreement about what they mean. Well, how can there be agreement if no one knows what they're talking about? No one can define the term. How can there be agreement on what? What are they agreeing to? What did they sign the contract to? So we got a serious problem, because these people cannot define the word point. They're going to use the word and they say, well, you know what I mean, you know? And no, I don't. I don't know what you mean. What do you mean by the word point? I mean, it's going to be the foundation of geometry, which is the foundation of mathematical physics. You know, space-time is described in terms of the point. Quantum particles are described in terms of the point. And so if you're going to use that as foundation for everything, you better define the point, because it's a very crucial, very strategic term. And you can't say, well, it's an undefined term. What do you mean? And as a minimum, I would love to know if they're saying it's an object or an abstract concept. It's either a physical object or an abstract concept. I mean, I'd like to know which of those two it is, okay? But when they say, well, it's the tip of a pen, well, they're talking about an object. That's the tip of my pen is an object. And if they're going to say, well, it's love, well, now that's a concept. So is the point love, or is it the tip of my pencil? We got a problem here, because we don't have even these notions established for the word point. Something as basic as that, okay? And remember, geometry is based on this point. This is what's going to build all the geometries, okay? Okay, so we go to another site to see if maybe someone can clarify this all for us, and this is what these people say. They say, math is about making definitions. Whoa, okay, love that. If you're doing geometry, then no amount of physical torture will get me to define a point. I love that one. What a contradiction. It's an undefined term, and it's undefined on purpose. Oh, okay, deliberately, okay? Hilbert's axioms, this is another, these are different sites, okay? Hilbert's axioms are a set of 20 assumptions, okay? The undefined primitives are point, line, plane. Again, saying undefined. The word point is often left undefined. Often? I thought it was always, not often. in geometry text. It is pretty easy for us to conceptualize a point, okay? But it is quite difficult to define exactly. Why would a point be so difficult to define? What's the issue? Okay, so you look up why it's difficult to define, and this is what they come up with. They say points, lines, and planes are the foundations of the whole system of geometry, okay? But point, line, and plane are all undefined terms. Whoa. How can that be? Yeah, how can it be? Well, any definition we could give them would depend on the definition of some other mathematical idea that these three terms help define. In other words, the definition would be circular. And another site says the words point, lines, and planes are left undefined. Again, everybody agrees on this, right? Or rather defined by usage in most geometries. In other words, what is called a functional definition. They define it at the end. First they use it, and then they say, well, if I forgot to define it, don't worry about it. Okay, we thus avoid circularity. Again, talking about circularity if we define a term, okay? Where definitions circle back to one previously defined. This tradition was only started about 100 years ago by David Hilbert. However, we can form definitions using our undefined terms. Well, I mean, I think you could say that about any word in the dictionary, that no matter what word you try to define, you're going to use other words, and those require other words and those other words, and so it's all circular, and we might as well not define anything. That's what these people are saying for the word point. So where do we stand? Well, apparently after all that rigmarole, we don't know what a point is. They can't define it. They're going to use it. They put a dot on the board, as you can see in some of those so-called definitions or non-definitions. They put a dot, and they say that's a point. Okay, that's a point. What is that? It looks like a smudge on the board, maybe an ink blot on the paper. Oh, what is that? I've seen we'll call it a blob. Is that a good word? Okay, we'll call it a blob from now on, not a point, call it a blob, or I don't know, smudge. And again, the question is this, whether it's an object or a concept. And these people try to clarify that point, okay? If you think about the structure of math as a tree, there has to be something at the bottom of the tree, okay? Some objects that aren't defined. Why? Objects that aren't defined, and you use those to define something else? I have no idea what this guy's talking about. A point is one of these objects, okay? So it's an object. Finally, we get a statement that a point is an object, okay? It is undefined. An undefined object. That's like saying a table is undefined. In science, we don't define objects. Maybe that's why these people are having trouble. Okay, we'll get to that in a minute. It is just an object. Again, stating it's an object. In geometry, people usually think of points, lines, and planes as undefined objects. Love the word object. Okay. And another site says many physical objects suggest the idea of a point. Examples include the corner of a block, the tip of a pencil, or a dot on a sheet of paper. Okay. Such things are called models or representations or pictures of points. Okay, pictures of points, like saying, well, I got a picture of an elephant. Okay, picture's a picture, although they show only approximately the idea in mind. I don't know what these people are talking about. I mean, I show a tree, I bring a tree, and I'm saying, well, this is a picture of a tree. You say, okay, and I say, but don't take it seriously. I mean, this is not really a tree. Well, what do you mean by that? I mean, let's go outside of my yard, and I point to a tree and say, well, this is a tree. Well, that's no longer a picture of a tree. It's the real McCoy. It's the real thing. And they say, yeah, but that's not the tree. The picture you had problems with. Now I'm showing you the real thing. You're saying that's a tree, but it's not a tree. It sounds like the people who do extinction. We're animals, but we're not animals. They love to have these dualities. It comes in handy for any discussion. You can always get away from being punished, right? Okay, so one way to get to the bottom of this, maybe, I don't know, because like you saw in the advertisement for this video, I showed that the ancients had no idea what a point was either. I mean, Plato, Aristotle, Socrates, all these, Euclid, they had no idea what a point was either. They weren't able to define it. But Euclid tried to synthesize the knowledge of the age of the ancient Greeks, and he put it in a book called Elements, okay? About 300 BC, about 100 years after Alexander founded Alexandria in northern Egypt. Well, this Greek guy was living there in Alexandria, and he wrote his book over there. And this is what Euclid tells us about, especially about the point. He wrote 13 books on geometry, and in his first book, he defines what a point is. And this is what Mr. Euclid has to say about it. He says, a point, first line, first definition, okay? A point is that which has no part. That's the translation we have today. He's saying it's got no size, no length, width, or height, no dimensions, no volume. That's what he's saying there. That's what we get from this. Maybe there's another interpretation, but that's the interpretation that was given over the ages, that what this guy was saying is that, a point is nothing. Yeah, nothing. It's equal to zip. And but then he says the ends of a line are points. So we have two ends of a line, they're points, okay? I don't know what a line is yet. We're not going to get to that until later. But I mean, right now he says the end of a line are points. So if a line is a physical object, he's saying that a point is a physical object. But this physical object or this object has no shape, no size, no volume, no dimensions. Is that what they're saying here? And then got another definition, number 16, and the point is called the center of the circle. Well, center is a concept. Center is not a physical object. I don't know of any object called center, but if you know one, bring it to the conference, put it on the table so we know what a center looks like. Okay, all alone, I don't want any other, just the center. Yeah, center is a concept, and so how can the center be a point and also the end of a line, which apparently refers to some kind of object, a line, right? It says the end of these are points, so we're thinking about something visible, with at least two dimensions. And then he says it's the same thing, the point is a center, which is a concept. So we got a problem. We already have a problem with Euclid because he's got a contradiction between his examples. He says in one case they form the end of a line. The other they form a center of something, which is an abstract concept. Okay? So we got a serious problem with the word point because it forms the foundations of physics on the one hand, forms the foundations of mathematical physics, really not physics. I call it mathematics. And it forms the foundation of geometry, which is the foundation of mathematical physics. And they haven't been able to define it in 2,000 years or more. I mean, talking about maybe 2,300 years at least. They haven't been able to define it. Okay, they don't know what it is. And it turns out that you stare at it, and here I'll show you. Can you see that? Someone draws that on the board, the red thing, okay? Just the red one there in the center. Can you see it? If you can see it, well, that looks like it has shape, size, as a minimum. It's got dimensions, height and width. You would think that it's an object. It represents what we would call objects, things that have shape, size, etc. And how can that not be defined if, either it's a concept and we define it, or we point to it and it's an object. And here I can point to it, and so obviously I can point to that thing because you can see it and it's an object, among others, reasons, right? And so we got a problem because this thing is going to form the foundations of this discipline we call geometry, and it turns out no one can define it, but what you're staring at is obvious. It's like you stare at a dog and you say, that's a dog. And then someone said, and then the guy tells you, he said, well, I can't define it. Well, yeah, we don't define objects such as dogs and trees and rocks. We point to them. And we can point to this guy. But if we point to it, then it's a dot. That's what is in front of our eyes. That is patently what is in front of your eyes. An object of some kind. It could be 3D, it could be 2D, no problem, but it's got shape, it's got size, okay? We point then and call it a point, then that's an object. So what's the problem? Why are they trying to define it after 2,000 years? You would think that they would have figured out that you can't define an object. That's the issue. And these people haven't figured that out in 2,000 years. That is astonishing. For me, it's astonishing that they have not figured out that you don't define objects, you point to them and name them. And if it's a concept, then you have to define it. And so maybe that's why they have trouble defining it, because they have trouble defining the concept. And what is the concept? It's a mixture between the object dot and what they purport to represent with this dot, which is location. So if you take location and you try to put it with a tree, they don't match. Location is a concept, tree is an object. And yeah, you can't blend them, you can't mix them, you can't, they're unrelated totally, okay? And, you know, I've drawn some pictures of this. Some of you have seen this in the past probably. Love, we represent with a heart. Good, right, we represent with an angel. Location, we represent with a dot, the so-called point. And I guess if you have half a point, that's half a location. I mean, is that what these people are saying, that you can represent half a location? Are we talking about things, or are we talking about concepts here? Okay, so let's look at the summary of what I'm trying to say here, okay, so that we keep this in mind. I'm going to continue with geometry these next few sessions. And here it is, the reasoning, okay. Geometry is the study of shapes and sizes. That's what they say that geometry is. Geometry is the foundation of mathematical physics, okay. Everyone claims that the point is the building block of geometry, but everyone casually confesses that they can't define the strategic word point. Everyone illustrates a smudge that has width and height, an object, something that has shape. Okay, despite staring you directly at what's in front of you, okay, at the 2D dot, the theorist tells you that the point that is in front of your eyes has no size, no volume, no dimensions, no shape. Let me look again. I see a purple thing that has size, volume maybe, you know, area at least, right? Dimensions and shape. And so how come the theorist is telling me that what my eyes are seeing are not what they're seeing? I'm seeing black and he's saying, no, you're seeing white. Huh? What do you mean? I'm seeing black. No, you're seeing white. So, you know, the way I like to look at this is that what these people are doing is this. You know, they're selling you a Whopper. They're selling you some snake oil here, some nasty Kool-Aid. You know, and so the question is whether you're going to buy this Kool-Aid, because remember, that's the starting point. They're going to build a whole structure on top of this so-called point. Okay? So I think the criticism is on the money. We have a problem, a serious problem, because we have geometry. It's founded on the point. The point is undefined. They can't tell you what's an object or a concept. Some people say it's an object. Some people later say, well, no, it's a location. And of course, if they can't merge the location with the object, with a tree, with a dog, with a rock, then we have a serious problem. We have, you know, a clash, because they're trying to reconcile a physical thing with an abstraction, with a concept. And no wonder they have trouble, or an impossibility, in defining it. They'll never be able to define it. And they can't just say, well, if we happen to define it, the definition would be circular because we need other words. No, that applies to any word in the dictionary. You need other words to define the first word. So we're done with that. We need definitions in physics, in science, because we need to talk rationally. So we need to understand what the dissertation is about and what the theorist is trying to tell you. The only way we're going to understand him if he defines the crucial terms, especially the ones that make or break his theory. In this case, point is a crucial term because he's going to talk everything about points. He's going to say that planes are points, lines are points, solids are points. He's going to say everything is point. Even four-dimensional space-time is made of points. He's going to say the particles are made of points in quantum mechanics. They talk about point charges and point masses. So clearly, if the word point is so important, they're going to use it every 2 seconds in all these disciplines or sub-disciplines. Well, all I can say is you have to define it. You can't say, well, the foundation, we don't know what that is, but let's continue and try to understand what I'm talking about. No, you can't do that. You got to define the point, or you got to establish at least if it's an object or a concept. If it's an object, if it's a dot, we're done. Use the dot. And if they say, well, we can't use the dot, the real dot, the two-dimensional dot, that's not what's important in mathematics. I don't care. That's what I have in front of me. That's what a dot, that's what a point is. That's what you pointed to when you said point. And if the dot is not the point, if that thing I'm staring at, that two-dimensional circle or square or whatever you put there, smudge, is not the point, then what is the point? And they say, well, it's a location. And if it's a location, why didn't you use the word location? Why did you have to use the word point and confuse me by saying stare at that dot and assume that it's got no dimensions, no size, no volume? But it does. The one that's in front of me does. Yeah, but make believe. Make believe it's not there. So this is the problem. The problem is we don't have a definition for point, not because the definition would be circular, but because they're trying to unite or merge or blend an object, a rock, with a concept, love. And yeah, you can't merge those two things because they're incompatible, conceptually incompatible. And so that's what they're trying to do with a point. They're trying to merge the dot with a location. And when they need the dot, they draw it on the board and they say, see, that's point A. And you say, okay, I understood that. And they say, but it's got no size. Yeah, but it does have size. Yeah, but see, the size is not important in math. What's important is the location that it represents. Well, why didn't you call it location? Why did you fool me? Why did you sell me this Kool-Aid, the snake oil, saying that dot is the point? I mean, if the dot is the point, let's use the dot because that's what's in front of me objectively. And if the dot is not the point, if point is really a location, use the word location. We don't need the word point. The only purpose of the word point is to try to blend two irreconcilable notions, an object with a concept, claim to the crowd that it's undefined, we can't define it, we don't know why, but we're going to use it and we're going to draw a point and use the location whenever we need it. That's why. That's the status of the point today. And after all is said and done, after I said all that, we don't use points in physics or in science. We have no use for the word point. Okay? Sorry that destroys your religion if it does, but I'm going to continue with that and show that we do have no use whatsoever for the word point. We have no use for really none of the concepts that came out of geometry and abstract science. We can call it science. Geometry has to do with measurement, and measurement has nothing at all to do with science or with physics. Okay, with that, I hope I gained enough rotten eggs and tomatoes on my face, and I'll see you. I'll see you on Wednesday. We'll see you then. Bye bye.